we are continuing to look at the buried treasure problem. In another video, I set up the equation for this scenario, which we can see modeled here. We're going to look at part 2 of this. So part A of this question asks for what's called the particular solution, modeling this function. The particular solution is just the equation of the graph, the particular function that would perfectly match that graph. If you remember, I didn't want to assume that it went through the origin. It looks like it goes through the origin, but we don't know for sure. We were told that the point 400, 150 was definitely a point in the graph, so I felt like it was safer to use a cosine function starting out at a maximum value to model it and kind of moving from there. Part B says to show algebraically that the sinusoid does contain the origin. So we weren't sure if it contained the origin, although it certainly looked like it. Basically, you could take the equation that we generated, which looks like this, and if you stick 0 in for x, you will find out that it works out to give you a y value of 0, or you can stick in a calculator as well. So that will work out. Part C is the part that I'm really interested in here, so let's go ahead and take a look at this. So the pirates bury their treasure at a point that on this model is located at the point 130, 40. And we want to know, would it be shorter to dig vertically or horizontally to get to the treasure? Okay, so I've got the function here, got a picture. So we're really trying to figure out this distance here. I guess vertically, it doesn't look very vertical, does it? We're trying to figure out that distance there. Or we're trying to figure out this distance here. And, you know, on the surface, that may sound really complicated, but really all we need to know is the coordinates of this point here and the coordinate of that point right there. And if we have those two things, this should come together pretty well. Well, think about it. If that's the point 130, 40, we're going over 130 and we're going up 40 to get to that point. That means the x-coordinate of this point here should also be 130, right? You're going to go over 130, and you're really just trying to figure out how far you go up to that point. Well, we've already got a function that allows us to put in an x value and to get a y value. So finding that y coordinate, literally, you should just be putting 130 into the function. Now, I've already set this up on my calculator. I graphed this previously. I didn't show it on a video, but just to make sure that it did match up with the graph correctly, which it does. Anyway, you can just go to the table here. You can start it off at 130, and you can go run your table. And it looks like the y coordinate there, it's the point 130, 65.643. If you scroll over, I think you'll find that decimal actually goes past 3 decimal places. You can kind of see down here. But anyway, about 65.643. And anyway, so if you come back and you look at the graph here, you know, we're over 130 for both of these points. That's vertical. So you really should be able to take 65 minus 40, and that tells you that that distance right there is 25.643 feet. So that wasn't a very big deal, okay? Now, horizontally, you're going over 130, and you're going up 40 to get to this point here. That point is horizontally related to it, so it should have the same y coordinate. We don't know the x coordinate in this case. It's something 40, and we would just need to figure out that point. So we know the y value needs to be 40. We're looking for the x. Well, just like we did before, we could substitute into this function, and we could solve this algebraically. So I know I want the y value to be 40, so I'll replace the 40, the y in the equation, with a 40, and then I'll just solve this equation. And we've done this earlier on another problem, so we'll see what's going on in this particular case. Okay, so I'm going to subtract 50 from both sides, and if I do that, that's going to leave me with negative 10 on the left-hand side. All right, and that's equal to 100 times cosine of pi over 600 times x minus 400. And then we can divide. We want to isolate the cosine function, so divide by 100. That's going to give us negative 0.1 is equal to cosine of pi over 600 times x minus 400. Okay. Now, this is all part of the cosine function. Very important to understand that. They don't always draw those parentheses there. But we can't get to this part inside parentheses unless we break it out. Remember, in a previous problem, we used the inverse cosine, or sometimes called the arc cosine, to switch this whole input statement and this output statement. So I can take the inverse cosine of negative 0.1, and I can set it equal to that pi over 600 times x minus 400. So I'll take the inverse cosine on my calculator here. Make sure you're in radian mode. Inverse cosine of negative 0.1. That's going to tell me it's about 1.6709. Okay? So that's going to be about 1.6709, and again, I'll actually keep that in my calculator, but that's going to be equal to pi over 600 times x minus 400. Still a lot to go to here. Now, you could distribute this. I think it would actually be easier if you get rid of the pi over 600. So I'm going to multiply both sides by 600 over pi, and what we're really doing here is multiplying by 600 and then dividing by pi. So I'm going to leave that answer in there. I'm going to multiply by 600, and I'm going to divide by pi, not by h, by pi. Okay, so we're going to get about 319.1305 is equal to, I still have that x minus 400 there. And so you can add 400 to both sides, and you have a final equation there. We find out that x is going to be approximately 719.131 meters. Now, here's the problem. 719.131. If you go look at our graph over here, 719, the x-coordinate here is 130. Remember, we were finding an x here. 719.131 is actually over here somewhere, okay? Now, remember what we did here. This is the point, we filled in a 40 for y. So this is the point 719.131, comma, 40, okay? And if you're wondering, what in the heck is going on here? Here's what's happening. This function is symmetric. And so if you draw the whole curve here, if you complete the curve, you're going to see that the curve would kick around like this, okay? There's a coordinate that is at this location here that matches up with this coordinate over here on this side. Okay, in other words, we can't determine which side of the cosine curve this is going to give us a value on. Okay, so the question is, well, how are you supposed to deal with this? Well, there are all kinds of trig identity rules that can allow you to figure out the location of these points. Oh, by the way, I'm sorry, I didn't draw this right. This is actually a point on the curve. It's a point right here. It's about 719.131, comma 40. Okay, we want the point over here that corresponds with that. Okay, this is on the curve and it's up 40 units, and that's on the curve and it's also up 40 units. Okay, so what happened was the inverse cosine function doesn't know which point we wanted. It just has to give us one of them, and then we have to figure it out. Anyway, there are all kinds of rules that allow you to make changes here. Here's my suggestion. This curve is symmetric. I didn't draw it very well, but from 400 over to 719.131, if you subtract 400 from this, you get 319.131. Okay, so that should tell you that it would be another 319.131 back to that previous point, okay? Because this is the middle of the curve right here. So if that's 319.131, so from 400 over to 719.131 is 319.131. We could go back 319.131 from 400, and that would give us that point right there. So I'm going to do 400 minus that answer that we got before, And that's going to tell us the point on the curve. It's about 80 point, we'll say 87. 80.87. Okay, sorry, that's a little hard to read, but we're going from 80.87 over to an x-coordinate of 130. Okay, so if we subtract those two values, 130 minus 80.867, we're going to get a length of about 49. Okay, so if they're digging in from the side, it's about 49 feet going that direction, and we saw earlier it's about 25 feet going vertically. So these pirates should dig in vertically. That's what's going on here. But again, this is a challenging problem because, again, the cosine function has infinitely many different points that have a y-coordinate of 40. And sometimes you don't get the one you want, and you have to think about the symmetry of the graph to try to figure out where that point would be that you were actually looking for when it gave you one that was different than what you wanted. So a tough problem, not one that I had an easy time with the first time I tried it, but I hope this video helps.